This is January 2016, paper 1, and this is question number 5. A student investigates the resistance of a lamp. We have to put an ammeter, a battery, a lamp, and a voltmeter in a circuit to test the resistance of the lamp. So what we're going to need is, this is a battery. So I'm going to need a battery. Terrible drawing of a battery, but you should do better. Make these lines a little bit thicker. There's our battery. Remember, the difference between a battery and a cell is one of these is a cell, two of them together is a battery. And then we're going to need we need an ammeter, and you can put that anywhere as long as it's in series. And then we've got our lamp, and then that should be connected back to here. And then we need a voltmeter in parallel with that lamp, and there's our 3 marks. So it's going to be, we need a circuit containing a lamp and some form of power supply. We should the ammeter in series, and we should have the voltmeter in parallel with the lamp, and that's our 3 marks. State the relationship between voltage, current, and resistance. That's an easy one. V equals IR, 1 mark, just stating. The student obtains this graph for a filament lamp. Calculate the resistance of the lamp when the voltage is 6 volts. So it's a calculate, and it's 3 marks, so we're going to have to show all our calculations here. They've just asked us to give the equation, so we can give that again. And R is V over I. We know that V is 6 because it tells us in the question. And then where are we going to get the current from? Well, we'll get it from the graph. And for a voltage of 6, it's going to be 1.5 amps. So the resistance is going to be, it's 4, and the resistance is ohms. You could have also write ohms here if you can't remember how to draw that symbol, but it's 4 ohms. The student reverses the battery connections and repeats his measurements. On the axis below, sketch the graph that he would obtain. So if the battery connections are reversed, then it's going to push the current in the opposite direction. So we're going to have a negative current and a negative voltage because it's going in the opposite direction. So what would we do? Well, first of all, I would try and find this point, the point where it really starts to change direction, and that's 1, 2, 3, 4. 1, 2, 3, 4 across. So we'll count 1, 2, 3, 4. So it comes from there, and I go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that would be the point that I would make, and I would draw the line then between those 2 points, and then it just tails off one like that. So that's how I would make sure I'm getting it exactly right. I would pick a couple of points along my graph and then try and plot the same points on here and then connect those up. And then that's our 2. It should be the correct shape, and the correct end positions should be ending in the exact same. So it's just a reverse of this one. The student replaces the filament lamp with a light emitting diode, an LED. He notices that there's no current in the diode when the battery is reversed. He replaces it with an AC supply. AC means alternating current, so the current changes direction. It keeps changing direction, whereas a DC supply goes only in one direction. Which graph shows the current in an LED? Current in the diode varies with time. It's not this one because we've got an AC supply, so we should see the current going up and down. The current, not this one, because this one just shows it changing direction once against time. So it's not that one. And it wouldn't be this linear change either. You just wouldn't see that for an AC supply. This is looking more like it. This is what we would normally see with an AC supply. So notice how the current is changing, negative to positive, and it's doing that as it goes along in time as well. So it's changing direction. But it wouldn't be this one because an LED only lets current through in one direction. So we can take out half of this graph because that current isn't allowed to go through the diode. So the only one it could be is this one, because this one is only showing the current going in one direction. The other direction for the current is not allowed to flow. That's a terrible drawing, but you get what I mean. Okay, that's question number 5.